Hey guys, Mr. Papanik here. We're looking to work on number 15 from assignment 31. We're solving trig equations. This is our third worksheet on these problems. You guys are choosing 10 out of the 15. So I'm going to do number 15 with you here so that you have an idea of how to go about solving these problems if you weren't in class or if you just want to review and walk through one of them. So what we're trying to do is solve for theta here. Right, so like any equation, you want to isolate that variable. The first thing I notice is that I have a -1 on both sides. So in essence, what we're going to do is we're going to add the additive inverse. If I add 1 to both sides, these will both become 0. Right, so that's kind of just hanging out there. There's really no need for it to be written to begin with, but of course, pretty easy to take care of. Right, so once you do that, what you have is 2 sine of -4 theta plus 3 pi over 4, right? And that's equal to negative square root of 2. At this point, we want to isolate the trig function, so we're going to divide both sides by 2, right? And that should kind of be nice because you should recognize this negative root 2 over 2 as a special value. So we've got sine of some angle, right? This angle that we're looking at is a full expression here, right? So these are relatively complex trig equations. And we know that sine of some angle is negative root 2 over 2. So we're trying to figure out from our unit circle what angle has a negative sine of root 2 over 2. Of course, that's quadrants 3 and 4, right? So if you had your unit circle over here, remember the sine is the vertical, and so you're going to find the angle somewhere in these two quadrants, right? Quadrant 3 and quadrant 4. Right, that's where you'll find negative vertical values. Right, so you have root 2 over 2, of course, at pi over 4. Pi over 4 is an angle in the third and fourth quadrant, is 5 pi over 4 and 7 pi over 4. So we know that this crazy expression for an angle, -4 theta plus 3 pi over 4, that's going to be equal to 5 pi over 4. And it's also going to be equal to 7 pi over 4. Right, and just so you can see where those came from, this one right here, that's my 5 pi over 4. Right? So we know that the sine of this big, like that greenish aqua angle, is going to be 5 pi over 4, right? Negative root 2 over 2, and then this other one, this orange angle, is our 7 pi over 4, right? So what we want to do is, again, we're still trying to solve this, so we're going to try to isolate that theta, subtract 3 pi over 4 from both sides, right? This is back to algebra 1 again. We're just solving an equation at this point. So we've got -4 theta equals, let's see, 5 minus 3 is 2, so we got 2 pi over 4. Of course, we know that's going to reduce, right? I'm going to do the same thing over here, subtract 3 pi over 4 from both sides. And I end up with -4 theta equals 7 minus 3 is 4, right? 4 pi over 4. Of course, both of these reduce, right? So right now, we're really looking at almost being done with this thing. What you definitely want to add in here, and sometimes we forget to do this, but because you've got a multiple of that angle, you then want to say, okay, this is plus some multiple of 2 pi, right? In fact, that has everything to do with it takes 2 pi to get around the circle. So no matter where we are, there's really an infinite set of coterminal angles. So we're going to make sure that we add k times 2 pi to each of these before we finish isolating. Right, so when we divide by -4, I'm going to multiply this side by -1/4 because there's a fraction here. It's just going to make things a little easier. I'll just show that work by multiplying by -1/4 here. So I end up with theta being equal to, let's see, 2 pi over 16. That's just plain old pi over 8. Negative pi over 8, and then this will be minus pi over 2 times k. Right, on the other side, I'll have theta equals pi over, let's say, 1/4. That would be pi over 4, negative pi over 4. And then this will be minus pi over 2k, right? So I've got these two equations, and they're expressions of pi involving k, right? K is just that counter, right? Remember, that's a natural number. So the first thing I'm doing here, or the next thing I should say, is I'm converting negative pi over 8 into some angle between, remember our unit circle, negative pi over 8 is going down a little bit, right? So if I'm going in the negative direction, negative pi over 8 is right here, right? So that's actually the same as, let's see, 15 pi over 8, right? So the coterminal angle with negative pi over 8 is 15 pi over 8. Because I'm subtracting off pi over 2, and I know it's going to be an eighth, I'm going to immediately just change that into 4 pi over 8, right? The same as a half pi. So what that does is allow me to very quickly list all of these. So 15 pi over 8, starting with the biggest, I'm going to drop by 4. Next one would be 11 pi over 8. Drop by 4 again, 7 pi over 8. Drop by 4 again, 3 pi over 8. And if I drop by 4 one more time, notice I'll be back at negative pi over 8. And of course, we're outside of that interval 0 to 2 pi that we're supposed to be solving on. Very similar thing going on over here. Because it's negative pi over 4, we're looking at this angle right here. It's negative pi over 4. Whoops, sorry guys. We're looking at this angle, negative pi over 4. That's the same as 7 pi over 4, right? If we're looking between 0 and 2 pi. So we're going to change this angle into a number between 0 and 2 pi. So I've got theta is equal to 7 pi over 4. And again, I'm subtracting, so I'm going to do 2 pi over 4. It's half pi. 2/4 is 1/2 times k. And now we've got the ability to just list, right? So 7 pi over 4. Next one will be 2 less. 2 less than 7 is 5. 2 less than 5 is 3. And 2 less than 3 is plain old 1 pi over 4. And there you have it. All 8 answers for theta.